Hey guys, a quick preview for you. This is a EMotorWerks 25 kilowatt CHAdeMO charger, and it's charging our Nissan Leaf at 25 kilowatts right now. As you can hopefully see here, the charge rate right now is 61.2 amps. The car is asking for 69, but the charger is set to 25 kilowatts max power, so it's limiting the power. It's been charging for a little bit, 4 amp hours into the pack so far, 39C heatsink temperature. Alright, and the rest of the video will show how it's made and how it's done, and we'll talk about a few details. Thanks. Okay, so here's the setup that we got here. There is a converted BMW in the back of the setup that provides about 300 volts DC from its battery. Then is going into this splitter that actually adds that voltage to this stationary battery bank that we have here, which is another 250 volts or so. The resulting voltage comes in as an input to the DC charger. This is a 25 kilowatt unit that will do 25 kilowatts from AC. From DC it will probably do around 40-50 kilowatt, and then it's running into the CHAdeMO controller, and CHAdeMO controller is feeding the Nissan Leaf. We are going to power the setup in a few minutes. In the meantime, this is the third component, high voltage capacitor bank on the input side. And inside, this is a power board. On top, the film capacitor board to soak up a lot of the transients and provide some immediate energy storage. And on the bottom below it is a universal driver board that is driving that 600. Actually, this is a 1200 volt 300 amp device, IGBT. And this is a 100 amp inductor that you see here. In the CHAdeMO controller, this is based off the Arduino board, which itself is based off the ARM chip from Atmel. It's a 32-bit. We are putting it on our own control board, which has dual CAN bus and a number of other features, including some relays for pre-charge and things like that. There is a sensor board right here that provides some redundant sensing of the voltage and current for CHAdeMO. And finally, all of this is getting out into the cable. Alright, let's power it up. Before that, let's see what kind of voltage we have on the inputs to this device. Okay, 527.28 volts from the batteries. This is a lithium battery bank, 527 volts. Okay, let's power it up. Let's look at what's going on here. So we have the charging going on now at 50 amps, which is a specified limit of this charger in our firmware. We are going to release that limit in a few minutes and go for even higher charging rate. So right now it's 50 amps. Let me just pause this flow here so that you can see. Okay, auto scroll off. So what you see here is basically the charger is constantly reporting the output current, and along with that it's reporting things like duty cycle and things like that. You also see the commands from the CHAdeMO controller. So the line that starts with M, 049, 410 is a command going to the charger from our CHAdeMO controller. So CHAdeMO controller takes CAN bus data from the car and interprets it into the commands for the charger. So this particular command says put out 49 amps until the battery hits 410 volts, and that's what the charger takes. And then another line that you see here, which is M, S as in Sam, colon, and then C 494 or 497 or 493, similar, and then V 394 and things like that. This is the charger reporting back to the CHAdeMO controller with the current that it's pushing, the voltage that it's seeing, its temperature, how much energy went through, and the timestamp. So for example, the last string like that you see on the screen says that the charger is pushing 49.2 amps. The battery voltage right now is 394 volts. The heatsink temperature of the charger is 23 centigrade, and so far it's been 0.6 amp hours going into the battery. Let's see what those parameters look like right now. Okay, so right now we have 49.4 amps, 397 volts, 31C heatsink. So some good temperature rise that you can see here, but not anything alarming. So let's see what's going on the car side. You can hear a 16 kilohertz pulse width modulation there that runs on the IGBT. The current sensor says 51 amps going out. The car says that it's happily charging, so everything's good so far. Let's check some temperatures. Let's see what IGBT temperature is like. 31, 32C, which is about the same as what the charger is saying, reporting back from the heatsink. The inductor, the output inductor there is about 35C, so again, nothing to be really alarmed of right now. Let's give it a minute, see if anything changes. The screen is dark right now because the charger is being controlled over serial line, which is this little wire going into the CHAdeMO controller. By the way, any charger from EMotorWerks, any DC charger, is now capable to be controlled by a CHAdeMO controller like this. So 12 kilowatt, 25 kilowatt, any of those chargers can be hooked up just like that, and you can control it from the CHAdeMO controller that could be plugged into a Leaf or a Mini EV or something like that. Okay, let's pause here. Okay, so we have now pushed about 6 amp hours into the battery. Still 50 amps, so the car hasn't started tapering down yet. The heatsink now is at 40 C, so it's slowly heating up. Otherwise, the charger and the car is doing well. The voltage is about 400 volts on the battery right now. Try stopping the system. So the charge stopped by user request. Hope you can see that here. This is what was received from the charger. Basically it said that the voltage is 402 volts right now, temperature is 42 C, and duty cycle when we were charging was 81.9%. And then the charger also gave the report saying that it pushed about 8 amp hours into the battery. At 400 volts, that would mean 3.2 kilowatt hours. And that's about it. Let's try to increase the current setting to 60 or 70 amps right now. So the current setting now is 70 amps. You can see it in the middle of the screen where it says QC can cap CH max out C. It says 70. So we're gonna re-upload this firmware onto the CHAdeMO controller and see what happens. The system is reset now, and we have allowed it to go up to 70 amps. Although, as you can see here, the charger is putting out just 61 amps according to its meter. 65 amps according to the current meter. The request is 35 amps now, so you get the idea. It's just going down very quickly. Since the car is getting almost fully charged. We are going to let it go through the charge and then see how it terminates. For next 15-20 minutes is probably not going to be an overly exciting show, but we'll come back when it gets closer to the end. Charging over there, some additional fun stuff for you. You've seen the plug that we're using now, not the most pretty one over there on the in the car. The new version is going to be much closer to the actual plug that is used by the official chargers. And big huge thanks to Joel Clemens out of Canada, who put in tons of hours actually getting this thing designed. So it looks pretty good. This is our print from the slightly modified designs. We're printing it at one of our vendors' facilities. The pins, the power pins, are the most problematic elements of this whole assembly, and we finally figured out where to get them machined, coming soon. And the new version of the CHAdeMO controller is partially assembled here. Some of the cables are not in yet, and the as well as some of the output circuitry. But this enclosure is about half the size. And on the board here there are many additional features that one could use for the future expansion of the system. Let's take a look what's going on with the charging. Okay, we're at 25 amp request by the charger, by the car, and 25.2, 25.8 amps output.